Hello, everyone. With a minute of delay, but we are starting yet another podcast about the technology. What I'd like to say first, Hartmut, welcome again to my show.
Thank you very much, Piotr, for inviting me.
I should mention that together with Hartmut, we decided that we will be meeting at least once a year. Yes. Because like today, the world is so hard to predict, and I have a feeling that every year is completely different from the last one, right?
So many things happening at the same time. The dynamic in our society, the dynamic in our economy is increasing. And I think it's whatever has been right actually about 1 year ago may not be right today anymore. So exactly. That's the reason why it makes a lot of sense to meet actually on some key topics on a little bit more on a regular basis. I'm very happy to do so.
Yeah, because this type of conversation can give us kind of like an outlook, and we can also give our impression what is happening with the world. And the reason why I think that it makes sense is that I watched our last recording, and when we discussed this kind of what is shaping the current situation, it was related mostly to the geopolitical problems, which obviously was the case then. But so what do you think that it's happening now? How do you see this year? From your perspective, from the technology perspective, what is shaping the world right now?
Okay. Yeah, I think unfortunately, in looking back actually at our last podcast, it's unfortunately not true that whatever has been or did exist about a year ago is not valid anymore today, because unfortunately the war is still going on and still having actually some major impact on our living environment. But having said that, talking a little bit more about technology, because this is our domain expertise, I think what really is more and more important shaping the technology being used is data. Data, if you look at recent analyses, people are saying actually that data is the new gold. That data is needed to lubricate any process. But what does it really mean? Because data is such an abstract and such a sort of like it can be looked at being sort of like very difficult to define. What does it mean using data? And this is perfectly correct because data are actually generated at each level of an organization. And when we're talking about an organization, we are talking about the entire global setting of an organization. I will give you hopefully easy to understand example. Let's take a look at the integration of supply chain and manufacturing. People may say, no problem, I do this already. I have full traceability across my manufacturing and my entire global supply chain. But now let's imagine actually somebody is having somewhere in the world a complaint about the quality of your product. Today it's easy to track actually when this product has been manufactured. There is already at that level, there's already some integration going on between the supply chain management systems and the manufacturing systems. But now you want to find out what is really the root cause of that quality issue. And if you want to find out what is the root cause, you need to dig into the production data. And digging into the production data means that you need to correlate actually a quality incidence with actually the production data. And this is not a trivial undertaking. This requires actually the integration of the IT and the OT layer from a data perspective. And I'm not talking about connecting actually some cables and some systems, but I'm talking about connecting or correlating the data at the IT and the OT level. So what we see actually more and more shaping the future is the convergence of IT and OT.
And it seems like a lot of organizations are already acting on this because like new technologies for production allows you to like make the use of the data properly. And then because now Ethernet is basically a network medium to go in the factory floor, then it makes it easy to integrate with high-level systems. Yeah, so definitely this trend seems to be speeding up. But do you see any like immediate disruptive types of changes as of now?
Yes, I do. And the one actually which comes immediately into my mind is artificial intelligence. But let me go back a step further actually before talking about the importance of artificial intelligence. I would like to elaborate a little bit more on the term disruptive, because you're asking what disruptive technologies are on the verge.
Yes.
And I believe artificial intelligence. If you go back, and probably not during your time because you're still much younger, but during my time, when I was at the university, it was actually forbidden to use calculators with programmable units.
Right.
In every exam, we actually had to take out the programmable unit, and then we could use the calculator, because the programmable unit at that time was considered being a disruptive technology. Today, nobody cares anymore.
By the way, there is this story that the teachers in the past, they wanted to actually ban calculators, right?
Exactly, for exactly that reason. Exactly, yeah. And now let's take a look actually what's going on today. Everybody probably have heard about ChatGPT. And ChatGPT is again considered to be a disruptive technology. Again, ChatGPT is artificial intelligence based. And people are now discussing how to prevent actually the use of ChatGPT for students actually generating their homework. Again, disruptive technology. We still need to figure out actually how disruptive that's going to be and how to deal with that disruption. But what I wanted to do is just elaborating a little bit on the disruption of artificial intelligence. And in our context, in particular in the data mining, data analytics context, looking at the massive amount of data being generated, just taking a look at the OT layer, every millisecond, dozens and dozens and thousands of data points are generated at the manufacturing floor. And how do you want to correlate the data with higher level data information? This is only possible actually using artificial intelligence. No human being actually is in a position to analyze these vast amount of data and making a good meaning out of those data. But only if you correlate the data using artificial intelligence engines, you can actually take advantage of your data.
Mm-hmm. Yeah, I mean, it seems like there is a need and there is an answer, because like in the last decade, the amount of data has grown so fast. And now we have this kind of tools like processing the AI on the edge, for example, to simplify the situation and to make things easier for us. But I think that the edge level is only a part of the story, in my opinion, because definitely you need to have some way of, making sense of the data, putting the data in the context on this low level, on the like a specific machine level, and I guess we will be discussing a little about that later. But how about like making sense of the whole engineering chain, or as you said, the supply chain and engineering chain integration, for example. So putting the data in the context for the whole factory, it seems as something that is much more difficult. What is your take on that?
Well, I think technologically it is possible actually to do this. you can actually create an entire factory model based around actually your sort of like data. The big question coming into my mind is, does this really make sense? Because you always need to ask yourself, what do you want to do actually with the data? You want to be able to take educated decisions and not actually sort of like mining through actually millions and trillions of different data points, but you want to take fast decisions. That's one point. The other point I would like to make is that a very recent analysis by the Forrester Group showed actually that only roughly 75% of the data are actually used. No, 75% of the data are not used. So that's even more impressive. So only 25% of the data being available are used actually to take educated decisions. And now let's take a look at actually a recently evolving management concept, which is called data-driven management. But how can you implement actually a concept of data-driven management without having all the data necessary? And not the data necessary in sort of like a really big context type of an approach, but in terms of manageable increments of being able to take decisions fast. And this is where I believe actually the use of disruptive technologies like AI on the edge will actually help companies, will help individuals taking educated decisions much quicker, much faster than looking at a holistic model of the entire factory.
Mm-hmm. It's a very interesting point because what we said at the beginning is like every year is different from another. Mm-hmm. And it's really hard to, for example, plan the production in the old-fashioned way, like in the past, that you were simply, analyzing the demand, historical demand, and you were trying to project this into the future, right? Yeah. The changes are so fast that we can't really predict what the demand will be, even for our products, right?
Well, and even I think if you look at the trend actually towards lot size 1, it's getting even more challenging. I think in the past you were producing actually your products like hundreds and hundreds of pieces, but now you only produce one. And this is creating actually much more of a challenge in terms of data analytics. Because how would you like to figure out actually if there's a quality incident with a product manufactured on a lot size 1 concept? How would you want to correlate that actually with the necessary process information if all those data are sort of like moved into a holistic data model of a factory? Almost impossible.
Mm-hmm. Yeah, responding to and acting fast on the changes in the world, the changes in the situations seems to be very important. And I think that this implementing this kind of concepts might be a bit easier for kind of like greenfield projects, mm-hmm. where you have a new factory. Some of the factories that are now being developed, they are like perfect examples of digital manufacturing, mm-hmm. concepts and so on. But it's much harder for brownfield because, mm-hmm. well, you have some legacy technology, you have some legacy production lines, and still you'd like to make this kind of fast decisions backed by all the data and the insights that you can generate from the data. So I think that we should discuss a little bit about how you can move from the point A to point B. Mm-hmm. And that's why I called this, I called this podcast Digital Journey with a Map. Mm-hmm. Yeah? So we would like to discuss a map a little bit. So what is the right path of moving to the digital future, let's say, mm-hmm. and how would you define the map?
Mm-hmm. Of course, I think it's very, very difficult to say in a very general way what is the right path, because it depends a lot on the individual environments of companies, of the factories. I think the question to be asked as well, in my opinion, is how can we minimize the risk of digitalization of our factory? And one of the ways to do this, to create actually this map, and you can probably relate to that yourself actually when you were actually spending about 3 years in Japan in the factory, which is sort of like the KAIZEN kind of approach. And as you've figured out and you've experienced yourself there is continuous improvement process going on, but not sort of like in big steps, but in a smaller step-by-step approach. So if you know actually what your final objective is, where you want to be, and then you actually divide this whole process you want to go through, or creating the map you were calling it, in very small individual steps. And this kind of concept is called KAIZEN. And KAIZEN, this is the very funny or very interesting part of this. KAIZEN is about 40 years old. And how can a 40 years old approach still help us today in the digital world, mapping out actually what we want to do? And the concept is very easy. It's dividing actually the map, the process, whatever you want to call it, into very small increments and steps, and then start executing. You can do this actually very easily on a brownfield without disrupting the process. And by doing it this way, it helps you actually to minimize the risk, which is always inherent to any project, in particular, turning sort of like a more analog way of production into a digital way of production. There is a high risk actually to do this. And if you don't do this in smaller steps, it's very difficult. And today, actually, this concept has been taken actually a step further than just the KAIZEN process. And it is now called the smart manufacturing at KAIZEN level. But the underlying concept is still the same, like from 40 years ago. And I think you are almost an expert actually in smart manufacturing KAIZEN level. So maybe you can elaborate on that and explain this a little bit more in detail.
Yeah, generally, I think that the map for manufacturing companies should be a type of a framework that you can implement and that you can always, look to the past, define where you want to be in the future. And this is where this kind of framework is the most necessary. So there are different approaches, as you said, to Kaizen. And I think that one is, for example, the Toyota method. Like you define the outcome, for example, what the size of the production should be, or what should be the, let's say, what is the preferred outcome in, let's say, 2 weeks or 2 months time.
Yep.
And then you define the way. So kind of like going backwards. Yeah. What we suggest with SMKL is something similar, but basically you try to define your position, how advanced you are in terms of digitalizing your production. So you can be, and you should be honest about this, right? So you should try to honestly answer, like, do I have the information on the average, worker level, or do I have the knowledge about the whole factory, right?
Yeah.
And then you're positioning yourself, and there are, like, when you find your position, there are natural steps to move forward, yeah? And then still you are realizing this in a Kaizen way, so very small steps, one at a time, but you can actually move to a very, high level of digital manufacturing with this map. Yeah. So I think that that's the concept. There was the video to visualize it, but of course we can explain this in detail during like specific conversations, because I think this is a first step to the digital manufacturing is to define the position where you are right now.
But I think it's very, very interesting, and I think it's linked very nicely to the discussions we had a little earlier about maybe it's better actually to use artificial intelligence at the edge to be able to take faster decisions, because this smart manufacturing at KAIZEN level will probably be very difficult to implement if you would have one holistic data model for the entire factory, because you would be sort of like missing out on some of the necessary information details to implement this SMKL concept.
Yeah, exactly. So I completely agree with this Kaizen approach. I think that too often we try to like do everything at once instead of defining these smaller steps that can be taken. And like the closer you are to the actual production, the more context you have to improve. Yeah? All right. So it's a journey. So let's say that we have defined our position using the SMKL methodology. What are your advices? What are the steps, these small steps that you can take, almost like on average, that would be the place to go? I mean, the solution to go. Do you have any examples how you would approach innovation?
Yeah, I think it's, again, it relates a little bit to what we're discussing about data. Whether it should be a holistic data model for the entire factory or for the entire company, or whether it should be more like an edge level kind of approach, being able to implement SMKL kind of concept. And this relates in the same way actually to the use of artificial intelligence at the equipment level. Yes, you can use artificial intelligence to make your entire factory becoming, so to say, intelligent. But the question is really, does this help you actually to get to your objectives you've defined for yourself? I personally believe a much better approach is identifying as well through SMKL type of methodology some of the bottleneck kind of applications or pieces of equipment. And then starting actually to make those pieces of equipment intelligent, to avoid actually the negative effect of this kind of bottleneck process. And you can do this at almost all component level. You can do this at the drive level, making drives actually more intelligent, being in a position to much easier implement preventive or predictive maintenance concept. You can use AI as well, for example, at the robotic level. If you have actually some AI capability built into the robot controller, you can much easier sort of like manage and control that single piece of critical equipment to your process. So what we are saying here is rather than trying to make an entire line intelligent by using AI technologies, just focus on your bottleneck application, for example, a robot cell.
Yeah, and once the production lines are more and more robotized, then basically what you are by implementing, for example, AI in robot arms, you are actually making the whole production line more intelligent.
Yes.
So again, you don't have to start from scratch and create like some perfect representation of our intelligent production line. You can actually do it from the bottom. So you install the robots, you equip them with this additional intelligence, and then step by step, gradually, the whole production is much smarter.
But the key to that is that you need to have this AI engine scaled down to be able to implement at the component level. Because if you look at very traditional software-based AI mechanisms, whether it's deep learning, whether it's whatever you name it, it's very difficult to implement at a component level. So you would need actually to have sort of like an AI capability, maybe a little bit spec down AI capability, but you need to have this at the component level.
Yeah. And then again, that is putting this particular data in context. Yeah.
Yes.
Yeah, I actually have another example of making things smarter one step at a time, and that is kind of like a cooperation of cobots with humans. And sometimes we tend to think that there is only either you install the robot and forget about, people in this production line, or we still keep the production manual and somehow we assume that it has to be faulty sometimes, so the quality will be lower and so on. However, I actually have another video to represent that, where we created a production cell for a human, for a person to work with, robot. And then the pick-to-light system is basically guiding the person. And then the robot is performing the jobs that he's better at, right? Robots are more precise and so on. But sometimes some manipulations are better done by humans, yeah? But then we can also control how operator is doing the job. And at the end, you have much higher quality and also much more insights into how the process is done, right? So I think this is a very good example and very nice representation of what can be achieved with small steps. However, you spoke quite a lot about the software already, and this kind of making use of the data. Well, on the factory floor, it can be solved in some sort of a hardware approach, but it seems like the software is creating more and more value in factories. What's your take on that?
I think you're spot on, Piotr. In my opinion, the hardware being used to automate processes is in the future becoming more and more of a commodity. I think we get to even some of the physical borderlines of technology developments. So the real value being created in the future will happen actually through, in my opinion, through two major areas. One is data, as we elaborated on earlier, and the second one is the necessary software to deal with the data. And this is sort of like relating this to, let's say, the factory level. What you actually, at the end of the day, want to do is you want to implement actually kind of a closed loop kind of control and management system by using different software capabilities. That means actually you would start actually to simulate a process. When you are happy with the result of the simulation, you implement this process, even by the means of virtual commissioning capabilities. And then you run the process and you continuously control the process by extracting the relevant data from your sort of like your OT layer. And then you're using actually the necessary software, which is again using artificial intelligence concept to analyze the data and to analyze not only the data but as well the quality related data as an example. And if you see actually, if you figure out through the use of the software that actually you're getting more and more close to a defined quality threshold, then you want to start manipulating the process again so that the resulting quality data are going to be further away from the defined threshold. So you want to manipulate the process by using the result of the analytics. By doing it in this way, you can actually implement a closed loop kind of a process concept. You can do this at the entire factory level. For example, if you are building a greenfield site, then you can actually do this sort of like probably holistically at the factory level. But the majority of the plants are brownfields, and you want actually to improve the processes as well at the brownfield site. So again, going back to the SMKL concept, doing this actually step by step, you would define actually the bottleneck processes and use the software in terms of simulation, in terms of data gathering, in terms of control of the process, in terms of analytics. And you apply this actually to a defined piece of equipment in your line, rather than doing this for the entire line. And then step by step, you can move actually to other pieces of equipment or other processes and do the same. So again, following the SMKL approach, step by step, you will be improving the process.
I actually had a similar conversation, which will be published on YouTube very soon, where my guest noticed that this kind of closed loops that are constantly improving your position, this is the competitive advantage of the future. Yeah? Mm-hmm. Because instead of, having like a committee to decide where to move into the future, how we can improve our factory, this happens almost automatically because you are acting on the data at each given moment, mm-hmm. right? Mm-hmm. So it is a way of staying this one step ahead of competition. And if you don't implement this kind of improvement processes, then almost by definition, you will be staying behind.
Mm-hmm. Absolutely. And I think there's probably much more details to be discussed with this single topic. And I'm very happy actually that you use a very specific dedicated podcast session to go more into the detail. I think we can only stay at the conceptual level at this point in time. But you're absolutely right and absolutely spot on. This is going to be a competitive advantage in the future. And again, I think to me, it really nicely sort of like fits actually to each other, like fits very nicely, looking at data, looking at artificial intelligence concept, and now looking at using software to implement closed loop control and management concept, providing competitive advantage to those who can do this.
Yeah, very good. And actually, I'm happy that we somehow moved to the topics of the outlook for the future, because usually I try to make this conversation lasting for like 40 minutes. So we have a couple minutes more. And I thought that maybe it makes sense that you could also share how you see the next years, what kind of trends you see emerging maybe. So we discussed where we are today, how we can move forward, but what is awaiting for us in the future, mm-hmm. in your opinion?
Mm-hmm. I think one of the areas actually we need to be aware of, I think, is that probably in the past we've taken the globalization a little bit too far. Too far in terms of moving a lot of our manufacturing capabilities into the Far East, and mainly for cost reasons. But interestingly enough, even manufacturing facilities requiring not so many human beings as workers in the factory were moved to the Far East. Now what we figure out is, and I think this was sort of getting very clear because of the pandemic situation, with numerous lockdowns in several countries in the Far East, that we couldn't actually get the raw material we needed to complete the assembly of our products in Europe. So what we are going to see happening over time now is what I would like to call being the reverse globalization. So we are going to repatriatize actually manufacturing from the Far East into the core European region. This is happening as we speak. If you look at the European Chip Act, for example, there's a massive investment now getting into building up our own chip manufacturing capacities in Europe. Because right now, we are almost 100% dependent on the US, Taiwan, and to some extent as well China. So again, becoming independent from sort of like the Far East as the key manufacturing base. This is one of the big mega trends. And we see this as well in talking to customers, where even there are customers now who change the supplier rating, including actually the dependency of the supplier's supply chain on individual countries in the Far East. So if you depend too much actually in your supply chain on a single country in the Far East, your supplier rating is going to be lower. So, but what does it mean? Reverse globalization and starting manufacturing more and more in Europe, considering actually the higher cost compared to the Far East. This will actually drive the need for higher degree of automation in the factory, and it will need as well a continuous improvement process in those factories to become more cost-effective and more efficient to be able to compete with the lower cost levels in the Far East.
Yeah, because I think that one of the reasons why the globalization itself happened was that like European manufacturing stopped being that competitive because of all of these things. And you're right that automation would be an answer how we can make it competitive again. But I am sure that this is not the only problem that we have. And for example, I can imagine another one being the energy costs, because we are trying to get greener in Europe, but that influences the cost of energy production. So do you think that this will be a challenge that we can overcome?
I think the just looking at the energy cost is probably a little bit short-sighted, being perfectly honest. I think it's more related to the use of energy, to use energy in a smarter way. I think everybody is aware of the climate change. Everybody is aware about global warming, and we see actually the impact of global warming more and more. I think you probably have seen actually the big flooding in Italy very recently. Again, it is a result of the global warming. And we will see actually those sort of incidents more and more on a regular basis to happen. So what it does mean is, in very generically, we need to reduce our CO2 footprint. And reducing the CO2 footprint, one way to do this is not just cutting the use of energy, but using energy in a much smarter way. Using energy in a much smarter way, actually, and this probably requires actually, again, a much more detailed discussion at some point in time. But you need to analyze the energy consumption, again, at the equipment level. It's not helpful if you know how much energy actually your factory consumes. But you need to do this at the equipment level, and you need to, based on that analysis, you need to come up with steps how to reduce the energy consumption at the equipment level. And again, we are getting to the point we made earlier. You can only do this if you have a good understanding of the data relevant for the energy consumption, and using as well artificial intelligence to correlate the different data to make the educated decisions. What can I do to reduce the energy consumption at the equipment level? And if you can do that, then the overall concept is very easily to apply, reducing the energy consumption. Of course, it's getting cheaper because of the high energy cost, of course. But at the end of the day, we will reduce our CO2 footprint. And in manufacturing, we actually will contribute to minimizing the effect of global warming.
You know, Hartmut, when we were going through this conversation, I thought it will be very difficult to summarize this because we touched on so many points. You know, we discussed the intelligent robots. We mentioned the frameworks like SMKL or the Toyota method and so on. And I was a bit worried how to summarize the whole story. But what I noticed is that any topic that we touched, we were ending talking about data. Because it seems like today's manufacturing is all about the ways of using data, how you can actually make sense of what is going on your factory floor, putting the data in context. And I guess that's the summary, right? So everything revolves around data these days.
Absolutely, you're spot on. And I think I cannot emphasize more the importance of the data and how you correlate the data in an efficient way to be in a position taking fast decision in a very dynamic environment. I think that really gets everything to the point.
Yeah, that's what I think. And let's summarize this conversation in that way. And so it's all revolves around data, and those who will be able to use it in a better way, they will get ahead.
Absolutely.
Perfect. We still have a couple of minutes, so we will finish at the full hour. But there are a couple of questions that we can now answer, if you're okay with that.
Yes, that's fine.
The first one was actually already answered because someone was searching for a global distributors of Mitsubishi Electric. So this was already answered. However, I wanted to mention this because it fits perfectly into what we discussed. So there was this question about using the Ethernet module on the compact PLC with MQTT communication. And it's just a perfect situation because even the compact controllers that are probably used in a small size machine, small to medium size machine. And now even those smaller machines are being connected to like high level systems, maybe to the cloud where the data from the machine is analyzed. MQTT is actually, very like perfect protocol for that. But, in, 10 years ago, no one was thinking about putting protocols such as MQTT into compact PLCs because what would be the purpose, right?
Mm-hmm. Yes.
But today it seems like even the smallest machines are connected to the cloud, data is analyzed, and that's perfect. And this is what we discussed.
It's a perfect example of what we discussed at a high level. You're absolutely right. Yeah.
But this is answered. So we have a list of global distributors on the website. The link is given. Next question is related to, it's a very good question. So do we provide consultancy services? So we discussed a little bit about the methodology, how manufacturing organizations can improve and go into this direction of digital manufacturing. But do we, as Mitsubishi Electric, provide consultancy? What is your take?
Mm-hmm. The answer is very simple. Yes, we do. The question is, how are we doing this? Talking about talking about Europe, yes, we can do this, but we have actually a dedicated group of people in Japan, in the factory, who are very experienced in looking into implementing SMKL methodologies or using SMKL methodologies to improve the process. So we can actually provide actually consultancy on a project basis through this group of people we are having in Japan. Of course, the number of people are limited, so we need to be careful about how and where actually are we utilizing those resources. But in general, yes, we can provide that consultancy.
Yeah, and I think that they'd be using SMKL to define the position of the company.
Yeah.
But then I think that the steps that can be taken are different for each organization.
Of course.
So definitely some sort of a longer discussion is necessary. But I think it's important that, we are making our own products, right? So we also have this kind of field level expertise about the production process.
Yeah.
Yeah.
And I think it's, and again, you had this experience while you were actually in Japan. We are following as well, sort of like the concept, do what you pray. So when we are talking about SMKL kind of methodology, yes, we are using this methodology in our own factory to continuously improve our factory. And we can actually have some consultancy about how to use this methodology. But at the end of the day, the implementation of such methodology is down to the individual customer. We can only help and guide the customer how to take advantage of that concept. But actually the final doing in terms of mapping out where the digital journey will take him to and what are the different steps, what are the critical pieces of equipment, this needs to be done actually by the customer himself, herself.
Yes, but we are already very present in Europe, right? So
yes.
we talk a lot about Japanese factories and so on. However, we are on European market for many years,
yes.
and we have this kind of expertise in our local offices. So I guess it all comes down to where is your factory, and then we can definitely find someone to discuss and
for sure.
position the organization in this context, so to say. Perfect. Another question is whether we will be present at Automatica in Munich. I think that the answer is no. So as you can see, we are doing a lot of stuff digitally now. So we try to be very present in digital space.
And there's one very additional sort of like piece of information. And it's a little bit funny. Particularly in Germany, what we have started to do is following more local, smaller kind of events. These kind of event series like all about automation. And this is actually where we believe actually the time spent is much more effective, because we can spend, we avoid actually customers having to travel actually further to visit a fair like Automatica. And having actually the chance actually getting into some conversation with us more at the regional or the local level. We believe as well that this is sort of like a little bit more of an efficient use of customers and our time rather than being at the bigger exhibitions.
I agree. And in this smaller type of event, it's easier to like hear exact issues that customers have. And
yes.
On the trade shows, like bigger events, it's not that easy to have this deeper conversations.
Correct.
Yeah?
Yes.
Yeah. It seems we are getting to the last question, and it's a bit detailed because it is related to the IoT security. So generally speaking, security, data security and so on is a very long topic that we might actually have entire podcast about.
Yes.
But I think that, so we can't really answer any like technicalities right now. But on more like a higher level, I think that we can mention on our approach to that topic. And I think that the main message would be that we prefer to keep data inside of the factory. And that's why this edge processing is very important, right? So we don't want to put all the data to the cloud and then worry about the security. We tend to keep the data in the factory on the edge level, right?
I think it's, you can probably not implement any of such system in 100% cyber secure environment. I think we see this actually happening on a regular basis, that companies are getting hacked, even though they may have actually good cybersecurity measures in place. But you definitely reduce the risk if you are using either a private cloud or using edge computing. What we can do as well is we have some experts actually in Europe, experts on cybersecurity, who can actually help customers to determine how to best use actually this technology in a cyber secure environment. But definitely the edge computing is minimizing the risk. It's not eliminating the risk, but it's minimizing the risk. It's going to be much different as well when we are talking about what's going to be discussed right now at the European level, like the Cyber Security Resilience Act, which is going to be implemented in the not too distant future, which will help companies to implement a more cyber secure environment. Does it eliminate the risk? No, even that will not eliminate the risk, but it can minimize the risk.
Yes, definitely. That's a topic that deserves actually a longer conversation at some point in time.
Yes,
because we are talking about the data, and then you need to find a way to protect it, and even more, you need to protect the machines, because machines are operating, maybe very important processes, so you don't want anyone to access that. That's some topic that we can discuss. Actually, we have a white paper on this topic. I tried to collect all the information that we have inside of our organization, and it was over 20 pages. So this is the longest white paper that we have. But if someone needs to learn a little bit more and go into technical details, this white paper is place to go.
Yeah, but one other thing to consider, and I just can offer that to you for maybe a future podcast series. Talk to actually one of our cybersecurity experts in Germany and see whether there's enough sort of like need for setting up a podcast like this one from today,
right?
Just dealing with the cybersecurity issues. I think this will trigger a lot of attention in the community.
Yes, I believe so. All right. There is one more question. Can we extend the warranty to 5 years?
Now let me try to give you a politically correct answer. I think we are very proud about our sort of like quality of our products. Normally actually you install a product and you forget about the product. But I understand the need of having a formal warranty. At this point in time, we are taking the position that you don't need a 5 years warranty because our products will hardly break within the period of 5 years.
Right. Yeah, but that's, I think, 3 years warranty period is already, I think, like, we are leading the industry in this.
Yeah.
The last point, could SMKL methodology be delivered as e-learning material? Actually, I I love this idea. So thanks for this. I don't think we have anything as of now, but I think we should develop.
Good idea.
Yes.
It's a good idea. Yeah. Yeah.
I think that it's a great idea and we will take care of it. Perfect. Hartmut, it was a pleasure as always. I hope we will meet not next year, right?
Yes.
But I guess the podcast we will do maybe in 2024.
Thank you very much for your time and for setting this up, Piotr, and thoroughly enjoyed myself. And now I wish you sort of like a nice weekend.
Thank you very much.
And to everybody actually online as well, a nice weekend.
Thanks a lot. Bye-bye and see you in 2 months.
Bye-bye.